Hello students, hope you all are enjoying school from home. Today is our final session on heat and temperature. Do you know how we are able to get heat while sitting around fire? Or how our hands get warm when we keep them in front of a heater? Or how the heat energy from sun reaches us when there is vacuum between sun and earth, and vacuum is a perfect insulator. It is through radiation. Now what is a radiation? Radiation. It is the process of heat transfer in the form of wave without any medium. Now you know the sun is very far away from earth. The outer space is vacuum and air around earth forms the atmosphere. Now infrared waves or radiations, these are electromagnetic rays. They can travel through vacuum as well as air. Heat transmitted in the form of infrared wave is also known as radiant heat energy. Infrared radiations are electromagnetic waves. Some other example of electromagnetic waves are given in your book. Here. It is from lower to higher frequency. These are radio waves, microwaves, infrared waves, visible rays, UV rays, X-rays and gamma rays. The visible rays, you can see the whole spectrum obscure in the form of rainbow after the rainfall. Now here is a car radiator given in your book. How does it work? It works on conduction and convection. What is its function? It gets rid of heat energy produced in the engine. This black portion symbolifies the engine. What is in a radiator? It consists of a lower chamber where cold water is stored. A fan is fixed. What happens when the engine is heated? Water is circulated around the engine. This water gets heated up and rises in the upper chamber. From upper chamber, when it falls down, the rotating fan cools it down, and in this way a circulation of water is generated around the engine and excess of heat which is produced by the engine is dissipated, so the engine is protected from the damage. What happens when these radiations are absorbed or emitted? When these radiations are absorbed or emitted, what happens is they are changed to heat. For example, if an object absorbs the heat radiation, it gets heated, and if it emits the heat radiation, it is cooled. Black, dull or rough surfaces are good radiators and absorbers, while shiny white or smooth surfaces are poor radiators or absorbers. Now here are few examples given in your book to show what is the effect of colors on the radiation process. We usually wear white clothes in the summer season. Now you might have seen Afghan people or the Arabs, they wear white turbans over their clothes. This is because they are good radiators of heat. They don't absorb heat, so we feel cool or they have a soothing effect. The black of the solar panels. The solar panels are coated with black paint so that they absorb maximum heat. The containers which are used to store oil or the inflammable substances are usually coated white. Our houses are painted light in color so that they give a cooling effect. Cooking utensils are also having shiny surfaces so that they radiate maximum amount of heat. The black of the refrigerator is also black in color so that they radiate maximum amount of heat which is produced by the compressor of the fridge. Prevention of heat loss. A vacuum flask is used. What is there in a vacuum flask? It contains of 2 layers of stainless steel, and in between it is vacuum. As we know, vacuum does not have any particle molecule, so it does not allow conduction or convection to occur. Now see this. This shiny surface does not absorb the heat energy, so anything which is kept inside the flask remains cold. The inner shiny surface, I can't show you this. There is inner shiny surface. This does not allow the heat energy to radiate if anything hot is stored inside it. Secondly, it contains a rubber cork, this thing. Now this cork maintains a seal and thus create a vacuum inside the flask, and in this way this flask helps in prevention of heat loss. The last topic of the chapter is thermal expansion and contraction. Thermal expansion and contraction occurs in almost all the states of matter. In general, solids, liquids or gases, they expand on heating and contract on cooling. Why this expansion occurs? It is because of the change in the intermolecular spacing. As I have told you earlier, the solids are highly compactly packed. The molecules are close to each other in case of solids. In liquids, the intermolecular spacing is larger, whereas in gases, the intermolecular spacing is further more. So, in case of solids, they expand to a very little extent because they are tightly bound to each other, whereas liquids and gases, they expand to a greater extent. Now see this example. This part will fit here when it is cooled, and as solid expand when cooled, the bar will fit into the gap, and when it is heated, we will not be able to remove it. We'll have again to cool it and bring it out. This ball will not fit in this ring, but if this ring is heated, the ball will fit in it. This is the reason. The expansion of the solid is the reason why the height of Eiffel Tower increases by 6 inches in summers. A few other examples of expansion in liquid are when your mothers boil milk in the kitchen, or they boil water or soup. They don't fill it up to the brim. They keep it low, as any liquid which boils, which is filled up to the brim, will move out because of expansion. In your book, there is an example given. Colored water is taken in this round flask, and if this round flask is kept in hot water, the level in the capillary tube increases. Here, if it is kept in ice cold water, the level of water in capillary tube decreases. This shows that the temperature outside causes an increase in the volume of the liquid when it is hot and decrease when it is cold. You might have seen the bread. It is porous. Why? Because the water which is used in making the dough, it changes to gas when it is heated, when it is baked. When this gas escape out, it causes the bread to be porous. You might have seen in the kitchen the chapati inflates because the water in the dough changes to vapors, and when it escapes, it causes the inflation of the chapati. Hot air balloons, they rises up as the air inside the balloon is heated continuously. What are the examples? Another examples of expansion and contraction, and where they are used in our life. Practical application can be seen. The rail tracks are laying a gap in between. If this gap is not there, they may bend or break because of the expansion of metal. The dental materials used in filling should have the thermal expansion equal to that of tooth enamel. If there is a difference in the expansion of filling material or the enamel, it will cause the breakage of the tooth, or it may cause pressure in the entire tooth, and we may feel sensitivity, or the tooth may be, and we must have pain. Another example is a thermostat. You might have seen it in an auto-cut geysers. What happened? What is a thermostat? It contains of a bimetallic strip. These two metals have different thermal expansions. When this strip is heated, it expands, but the rate of expansion in both the metals is different. So it bends and contacts the metal tip over it, and it completes the circuit. This is how the circuit is complete, and the water will remain hot. Once the temperature is attained and the heat is removed, it will again contract and will switch off the button. Thus it works to open and close the circuit to turn the heater on and off. With this, we finish our chapter. In between, questions and book pages covered will be uploaded on the school website. Thank you.